Okay, the glug activity was just a simple activity to show you, okay, depending on how much accuracy we need in our number, we'll choose different measuring instruments. And of course, we'll say, well, shouldn't we always just be as super accurate as we can? In some cases, it's unnecessary, and in some, not in the glug one, but in some it takes more um, effort and using precision equipment that we don't actually need. So, so let's build on that glug activity to really get into significant figures. I want to show you conceptually the idea, and then what you may want to have is that Google document significant figures with you, so you can pause the video and go there, unless you can show both at the same time. So you can kind of cycle back and forth between this video and that significant figures Google document. That's part of this assignment. So let's talk about conceptually first, and then we'll get into the rules. Let's say I want to go from Monrovia High School, or from Monrovia, California, to San Antonio, Texas. And of course, normally we would Google Maps it, how far is that, but that's taking the roads and stuff. Let's say I'm going to fly. So I want to know how far is it as the crow flies. And somewhere I had remembered something, and someone said, oh yeah, it's 1,300 miles. I don't know if that's actually, I think it's close to that. That's 1,300 miles as the crow flies. Again, I can't use Google Maps because Google Maps roads aren't going straight there. So that number is an estimate, right? So it's an estimate, and what tells me that it's an estimate? I've got 1, 2 significant digits that are saying something about the accuracy of that thing, but those zeros, these 2 zeros there, are just placeholders. So it has 2 digits that are saying something about how accurate is that measurement, or in this case, estimate. How accurate is it? It's got 2 digits. Those 2 zeros are not significant. They're just placeholders. And so it's saying it's an estimate. It's about 1,300 miles. What if someone had been there and said, oh yeah, I've been there and I flew that thing, and it's actually, yeah, it's 1,330 miles. So now that I'm getting a little more precise, you can tell from these 2 numbers, this one has a little more precision, hopefully if the guy knew what he was talking about, in that number. So these are more precise numbers. So the number of digits, 1, 2, 3 now, says something about the accuracy. Let's say I go ahead and instead I'm going to use GPS data, and now that I'm being more accurate, I got to be more specific, not anywhere in San Antonio, not anywhere in Monrovia. From room 921 at Monrovia High School to a particular street corner, maybe the Alamo, the front door of the Alamo in San Antonio, Texas. And I'm making this number up. It may not be accurate. 327.1 miles. So when I look at the difference, 1,300 miles or 1,327.1 miles, this says this measurement, if it was done correctly, has a lot more accuracy to it. The more digits in a number, the more significant digits in a number, the more it indicates a certain level of accuracy. And that's going to be important for us in chemistry. So let me get to the rules. And what I've got is I've got that significant figures. There are 6 rules on there, and I'm going to go through them quickly one at a time. The first one's super simple. All non-zeros are significant. So really when we're talking about significant figures, if it is, we're only saying, hey, is a 0 significant or not in a number? So if 123, that has 3 digits, there are 3 significant figures. I'm going to abbreviate significant figures, or sig figs, just SF. So rule 2. Now, so the rest of the rules are, hey, is a 0 significant or not significant? And it depends. If it's sandwiched in between, what if I have a number like 103? Maybe it's 103 grams, right? If I have a number like 103, that's accurate to the ones. I'm saying it's not 102, it's not 104, it's 103 grams. So it's accurate to the ones. That zeros that are sandwiched in between non-zeros are significant. So that also has 3 sig figs. So zeros in between non-zeros. Another example could be 0.001. 0.004, and maybe this is milliliters. So those zeros, this is accurate to the thousands. Those zeros sandwiched in between non-zeros are significant. This would be 4 sig figs. Right, so zeros in between two non-zeros are significant. Let's get to rule 3. Rule 3 says zeros on the left side of the number are not significant. If I want to go 0.01, and all that zero is doing, this one, sometimes we could say 0.01 or 0.01. These zeros are not significant. That zero is a placeholder, moving that over to the thousands. So there's only one number in there that's significant. That is 1 sig fig. If I have a number like 0.00104, so I put the first for these two rules. So all these zeros are to the left of the number, not significant. They're placeholders moving this thing over. I've got 1, 2, 3. This zero is sandwiched in between non-zeros. It is significant. That would be 3 sig figs. So that's rule 3. Let's go to rule 4. Zeros to the right of the decimal point and the right of non-zeros are significant. So we can call this the right rule. So if I've got something like this, 0.01, but I want to show that, wait, it's more accurate than that. I use some accurate equipment. 0. I could do something like that. So I'm representing that this number is accurate to 3 significant figures. So if they're to the right of a decimal and the right of non-zeros. So these two zeros are to the right of the 1, and they're also to the right of a decimal point. They are significant. That is 3 sig figs. Another one. So if I want to show, like, hey, I want 1.0 gram, and I just put a 0 there, I'm trying to say, no, not just about 1 gram. So 1.0 gram accurate to the tens. So that 0 is significant. That would be 2 significant figures. Okay, let's go to rule 5. Zeros to the right of non-zeros and to the left of an unwritten decimal point, so key is unwritten there, are not significant. 10,500. So 10,500, let's go liters, right? I got 10,500 liters. This zero is sandwiched in between two non-zeros. Those two are there as placeholders moving that over, so they are not significant. So that would have 3 sig figs. So notice if they're to the right of the number and there's no decimal point, they are not significant. They're just placeholders. What I can do, so what if I want to show like 100, but I want to say, well, wait, I want exactly 100. I want it accurate to the ones that I want to show that actually those are going to be significant. How can I do that? If I put a decimal, right? So if there's an unwritten decimal point or there's no decimal point there, zeros to the right of the number are not significant. Put a decimal point in there, and I'm saying, no, 100. 100 grams. Measure out 100 grams, not 101, not 102, not 99, 100. I put a decimal point there, and sometimes you'll see in our materials we put a decimal point after the number. Why? I don't really need it to show it's 100, but what I'm doing is saying these zeros are significant. It's accurate to the ones, so that would be 3 sig figs. So no decimal point there, zeros to the right are not significant. A decimal point there, zeros to the right are significant. What if I want to say, no, it's actually 100.0. Let's get accurate with this measurement of 100, 100.0. These zeros, of course, there's a decimal point, but also this 0, it becomes significant because to the right of the number and the right of a decimal. So because it's significant, these would be significant anyway. That is 4 sig figs. 1, 2, 3, 4. Okay. Sorry. Rule 6. Scientific notation. I'm not going to do any kind of scientific notation on this video. I'm assuming you guys have it. We use it a lot in chemistry. If you're not sure, you're a little rusty on it, there's tons of tutorials on the internet. So you know, practice up if you're not practiced. But let's say I've got a number like 1,200. But I actually know the accuracy of that number to 3 significant figures. How do I do that? I can't put a point there because that changes 1,200 to 120. What I can do is change that number into scientific notation. So all of the numbers, you know, in a scientific, when I'm writing scientific notation, if I just put 1 point, so what's 1,200? 1.2, I'll leave a space to add something, times 10 to the third. I want to show, hey, wait, I know this to 3 sig figs. 1.20 times 10 to the third. All of these numbers that you write when you're writing scientific notation are assumed to be significant. 3 sig figs. That's how you would show 1,200 to 3 sig figs. So if I'm showing 1,000, whoops, 1,000, and it's an estimate, it's crude, I would just put 1 times 10 to the third. If it's 1,000 and I know it to 3 sig figs, I'm going to put 1.00 times 10 to the third. And so I can just put whatever zeros in there, or whatever number of digits in there, to make it so that I'm showing how many sig figs are in that number. Okay, so there's our rules, and I've got some practice to follow. And I'm going to actually have you guys try that, and I'm going to give you the first 5 answers. One quick note on multiplying and dividing. We've practiced that a little bit with Google. If I take a really accurate number, with the glug activity, 1.250 times 10, and there's no decimal point, it's only accurate to 1. 1.250 would be 12.50, right? I multiply by 10. But this measurement, I was really sloppy. I didn't have any accuracy in that. Because I'm showing that only has 1 sig fig, I've got to round my number to 1 sig fig. This has 4 sig figs in it, but that one only has 1. This one's limiting my accuracy. So I actually have to round to 1 sig fig. Let's see, 1, 10. Right, so if I make one really accurate measurement and one not accurate, and I'm using those in a calculation, then this non-accurate one means my answer has to be shown that it's not accurate. Okay, and same thing with addition and subtraction. I have some practice for you there, but let's say I have 2.15 grams and minus 0.009 grams. So let's see, what do we got? A 2.141. Did I do that right? I think so. So what I have to do is I have to show in my answer, wait, this one limited my accuracy. It was only accurate to a tenth. I've got to round it. Since this was accurate, to a hundredths, this was accurate to a thousandths, but because this one was only accurate to a hundredth. So when subtraction and addition, I look at the decimal point. To what place is my number accurate? And whichever one is the least accurate number, that's the one that limits my accuracy. With multiplication and division, it is all about how many digits in my numbers that how many significant digits in my numbers that I'm multiplying. So there's practice on there. What you should do is pause the video here, try on the Google Docs the first 5 answers where we're rounding. Like number 1 is 1278.0. And I'm just going to run through the answers quickly to see if you got it. So pause the video, try the first 5, and then restart it, and we'll go through the answers. So I'm going to go through the answers now. 1278.0. There's a decimal point, and that 0 is to the right of the decimal point and the right of the numbers. 1, 2, 3, 4, 5. 5 sig figs. Right? right? So that's that right rule. Number 2 is 1, 2, 0, and there are 4 zeros. I'll put a comma in there, 120,000. No decimal point, those numbers are to the right. All of those zeros are not significant. That would be 2 sig figs. Number 3. Okay, these zeros are sandwiched in between non-zeros. They're significant. These are to the right of the decimal and the right of the number. they're also significant. 1, 2, 3, 4, 5, 6, 7. 7 sig fig. And then, oh, so many zeros in this one. This is number 4. 0.0053, 5, 6, 7. You get that? Yeah. Okay, all of these zeros are to the left of the number. 1, 2, 3, 4, 5. 5 sig figs. And the last one that I'll cover on this video, 670. That's easy. 0 is to the right of the number. There's no decimal point there. It is a placeholder. It's not significant. That has 2 sig figs. All right, try the rest of those. Try the multiplication and division ones, and then turn this assignment in. And then we'll be ready. Once we got these rules down, now we're ready to do some labs and make some measurements and know something about, well, what equipment should we use to get the kind of answers we want. So we'll see how that goes.